Assalamualaikum warahmatullahi wabarakatuh. So our group is about lab equipment checkout and tracking system. So this is our team members. So for the introduction, um, the equipment tracking system helps the engineering department. So for our project is about the lab equipment that students borrow and return. And student can ask for equipment online. Technicians send it out and bring it back. And the system updates the inventory automatically. So for the project background and operational driver, for the first problem for our system is about manual borrowing process, which is students must contact lab technicians directly or use manual records to borrow equipment. And this causes delays and increases administrative workload. So for the solution is provide an online portal for students to submit equipment requests and streamline the borrowing workflow to improve efficiency. So the second problem is about document and record loss, which is manual tracking can result in misplaced records and incomplete borrowing information. The solution is we store all equipment requests, loan records, and return records in a centralized database. And the third problem is our inventory inaccuracy, which is the equipment availability is difficult to track accurately. Uh, it leads to incorrect information about available items. So the solution is automatically update inventory records when equipment is dispatched or returned. And it perform real-time availability checks before approving requests.
Now, let's start with context diagram. We show the single system black box and interaction with outside world. We have three internal entities interacting with our system. First, the student. They submit an equipment request. In return, they receive an overdue warning if they are late and an overdue penalty notice. Second, the lab technician. They receive an overdue notification to track delinquent items, and they provide the system with dispatch confirmation and return log to update equipment status. Lastly, the finance department. They are the final recipient. The system send them an overdue penalty notice so they can handle the billings. Now we zoom in. The level 0 DFD breaks the black box into three core processes and two data storage areas. First, process 1.0, process equipment request. When a student requests equipment data, the system checks the inventory data. D1 for availability. If available, it sends the request detail forward and notifies the student. Process 2.0, manage dispatch or return. This is where the lab technicians step in. They handle the physical dispatch. The system updates the inventory data D1 to reduce stock and save the loan's information, including due dates, into the loan record and data store. Process 3.0, handle overdue items. This is the monitoring process. The system checks the loan record against today's date. If an item is overdue, it sends an overdue warning to the student. If it remains overdue, it escalates and sends a formal overdue penalty notice to the finance department. Notice how all three processes share and update the central data store to keep information consistent. Finally, we drill down one more level into level 1 DFD to see the interface steps inside those major processes. Let's break it down. For process 1.0, request handling, the system first receives the request, validates it to ensure the student is eligible. It queries the inventory data to check availability. Finally, it notifies the student whether the requested item is ready or not. For process 2.0, dispatch and return, once the technician confirms the dispatch, the system records the transaction, creating a long record with specific due dates. It then updates the inventory master list and the technician confirms the returns, which update the record again. For process 3.0, overdue handling, this is a sequential flow. The system runs a job to identify overdue item from the loan records. It generates a warning to the student if the item is still not returned after a grace period. It generates the penalty and sends a final notification to the final department to proceed with the fine collection. This level of details show the exact sequence of action that happen behind the scene for every transaction.
Okay, hello. I will be explaining the use case diagram, which you can see in the slide that they have three actors: the lab technician, finance, and lab technician and finance department. And for the activity diagram, it acts as behavioral flowchart mapping operational workflow step by step using swim lanes to split responsibility across the student, system, and technician finance personnel. Okay, next I will be explaining the sequence diagram. This diagram illustrates the chronological flow of message exchange between objects over time for specific system scenarios. Okay, this is our UML diagram. It's a system showing the main domain entities, classes, the internal and external attributes method, and how they relate to one another. For example, with the students, they represent the borrower. They can invoke request equipment and return equipment. Okay, now this is our reference for our project, and thank you.